Oracle Net Services. In this nugget, we're going to talk about the features and benefits of Oracle Net Services. If you want to have your machine talk to an Oracle database that's not sitting in front of you, then you need to use Oracle Net Services. One of the benefits of Oracle Net Services is that you can have a heterogeneous distributed environment. What I mean by that is that you can have several databases that are working together. You might have one on Windows, another on Linux. You might have one on 10G, another on 9i. And these databases can be queried together in what we call a distributed query. And what's nice about this is that it requires little networking knowledge on the OS level. Oracle takes care of all the fine details for you. And then we'll talk a little bit about performance and security benefits. And then we've got our listener. Think of the listener as your phone ringer on your cell phone. If you don't have your ringer on or you're not in vibrate mode, you're not going to pick up any phone calls. Well, the listener is the same kind of concept. We've got a tool called the database listener that is just waiting for clients to tap into it, and then it hands off the connection to the database. And all the listener is really doing is handing it off. Let's say that we have some clients that are already connected to the database and you shut your listener down. Well, that's not going to affect those clients. But it is going to affect clients that are trying to connect currently. From the client end, you might be trying to connect into a database called ORCL. So you might say, okay, SQL plus, the username, and an @ sign, and then what we call the service name of the database. Think of this as an alias. Okay, so let's say that the alias is ORCL. Well, this ORCL here needs to somehow be resolved to the host name and the port number that the listener is on. And there's several different ways that we can configure this service name. We can use local naming. With local naming, we have to configure a file called tnsnames.ora. And that's the only file we have to configure there. Another option might be to use an LDAP directory. That's kind of beyond the scope of this nugget, but just know that it's out there. What's new to 10G is something called Easy Connect, which involves no configuration files. You just provide all the connection information up front. For example, you can say, okay, I want to connect as Scott, and then you specify the host name, followed by the port number of where the listener is on. If it's 1521, which is a default, you don't even have to put the port number, followed by the service name if there are more than one service on that machine. Then we'll talk about some of our troubleshooting tools. On the operating system level, if you're trying to see if your client can actually connect to another machine out there, you can simply use ping. We also have a TNS ping to see if this name up here, this service name, is a good service name, if it's configured correctly. Then we'll take a look at some trace files as well as log files. And then lastly, I'll show you what a distributed query might look like. One of the benefits of having Oracle Net Services at our fingertips is that we can have a heterogeneous distributed environment. Like I mentioned, heterogeneous just means, okay, we can have a hodgepodge of Windows machines and Unix, Linux, and you can have all of these different databases on different machines connect with each other. And they don't even have to be the same version. You might have a couple on 8i, 9i, 10G, not a problem. In fact, you can even have your database talk to an external program like a C program. And no, you don't have to be a networking genius to get all this done. In fact, by the end of this nugget, you should feel pretty comfortable with networking a couple machines together and creating a distributed query, which I'll show you in just a moment. The configuration files that you'll be dealing with are usually going to reside in the Oracle Home Network Admin Directory. If you want to override this directory where those files are, you can create an environment variable called tns_admin, and you just set that to whatever directory you want to. But here I'll just stick to the defaults. Okay, so let's see what's in this directory. We've got a listener.ora file that's used to configure our listener. I'll show you some detailed examples of that in a moment. We also have a sample directory. That's just a directory that contains some samples of all these different configuration files, and it also contains within those files some really nice comments so you can have a clue as to what all the different parameters are. You have your SQLnet.ora file. Think of this as a file that can configure all sorts of miscellaneous things, such as, what your naming methods are, how you want to perform authentication. And then we have our tnsnames.ora file. That's going to be used only if you're using the local naming method. By far, using tnsnames.ora is the most common way of creating an alias for a database. Now, as far as performance goes, you can configure things such as in your listener.ora file, you can specify that you want to use shared server for a connection instead of a dedicated server. We'll talk more about that in our next nugget, but in a nutshell, shared server architecture simply means that you're pooling together a bunch of connections instead of having one connection to the database for each client. Well, let's talk about our listener. Remember, the listener is there to listen for incoming connections from clients to tap into your database. If the listener is down, then no outside clients will be able to connect into that database. So we have a command line utility called listener control, and you can execute it from any directory. You say lsnrctl, and then we get our prompt. So then you can just type in status and see whether your listener is up or not. So ours is up. If it wasn't, it would tell us that it's down. And in the description, it tells us our host name. It can either be the host name or the IP address, and then the port number. So the default port number is 1521. If you have multiple listeners, they're all going to have different names, and they must be on different port numbers if they're on the same host. If you have just a standalone Oracle instance, then you most likely will just have one listener. But let's say you're in a rack configuration, that stands for Real Application Clusters, where you've got multiple instances tapping into one database. Well, in that case, you'll have one listener for each instance. Now, the information configured in here can actually be set in a configuration file called listener.ora, which by default is in the Oracle Home Network admin directory. In fact, let's go there right now. We're in the directory right now. If we want to look at the contents of that, we just say listener.ora. Okay, so here is our listener configuration file. So right down here where it says listener equals, that's the name of our listener. We could call it anything else. We could have called it listener 2, listener 3, or whatever. And then we have the protocols that it supports. There's more than one protocol. For example, we have TCP, we have TCPS, which is secure TCP. We have the NMP if you're using named pipes, if you need to execute some kind of external procedures. And we have IPC for inter-process communication. By far the most typical is going to be TCP or TCPS. Another part of our configuration is the SIDs, the Oracle SIDs that your listener is listening for. It's basically the SIDs that your listener is aware of. So here we only have one SID that the listener is aware of, which is ORCL, and then we give the Oracle home of that SID. You might have multiple instances that your listener is aware of, and all you would do would be to copy this part and paste it right down below and make the modification, specify the SID and its Oracle home. So in other words, your listener can be listening for multiple databases. So if you need to modify your listener, you can actually open up this file with a simple text editor, or you can use the GUI tool that Oracle provides you with. I'm going to show you an example of using the GUI tool. So let's say netCA, that launches our GUI tool. Once again, you can launch that from any directory that you want to. So we want to configure our listener. So we hit next. And then we can reconfigure our listener, or we could add another listener if we wanted to. Let's reconfigure. And there's only one listener here in the drop-down. Now, our listener is currently running. Do we want to stop it and modify it? Sure, we want to. Just keep in mind that anybody who tries to connect to the database right now will not be able to because the listener's down. Okay, so if you want to also support TCPS, you can go like that. Now, if I move this TCPS up, it just means that the client will try to use this protocol first and then TCP. And then we can hit next. And we can specify which port number. Now, for TCPS, the default port number is 2484. We'll just stick with the default. And then it asks us for TCP what port number do we want to use? And we'll stick with 1521 still. Do we want to configure another listener? No, let's not bother with that. So we'll see some information splash across the screen here down below. And it just takes a minute for it to save it and restart it. And then we hit next, and then we can hit finish. Now we can then type in LSNR CTL and get the status. And you'll see now that we have two different protocols supported and the port numbers there. Let's look at some other options in our listener control utility. If you simply type in help, it gives you all the different commands you can issue. We have stop and start. So if you want to stop your listener, you simply say stop and then the listener name. If your listener name is simply listener, then you don't have to put the listener name. You just say stop. Okay, same thing with start. After we stop it, we can start it. If you decide to go into that configuration file manually, and make any changes, then you simply have to either stop it and start it again, or you can say reload. I'm just showing you now how I can restart this. Okay, looks good. It's a really good idea to password protect your listener to prevent regular users on the operating system from starting and stopping your listeners. Okay, so it's actually a two-step process. You are going to change the password, then you call the set password, and then you save the configuration. So here we say change password, and we put in our old password. Now if you didn't have an old password, then you just hit enter. Then it asks for your new password twice, and you'll see that it's been changed. So now you say set password. So that command actually sets it. You have to type in what the new password is and then save the configuration. Okay, so now a regular user, if they're going to start or stop the listener, they actually have to provide that password. One of the little-known features of the Oracle Listener is to allow it to include or exclude clients from a particular host. For example, if I only want to allow connections from a particular host, what I can do is edit the SQLnet.aura file. And that is going to be in your network admin directory. And what we can do is add an entry that first of all turns on this ability by saying TCP valid node underscore checking equals yes. So we're turning that on, and then we can supply a list of nodes that we want to invite. So here we'd say TCP dot invited nodes equals, and here we can have in parentheses a comma-separated list of hosts. For example, if our company has the node of my company and perhaps my sister company, we can do that. Or we can put IP addresses in there. Or if you want to exclude particular nodes, you can say TCP dot excluded nodes equals, and then a comma-separated list. Now keep in mind that these two attributes here are mutually exclusive. If we exclude particular nodes, then any other host is accepted. Now that we're looking at our SQLnet.aura file, let's take a look at this entry up here as well. The authentication services equals NTS, that simply allows Windows to perform Windows authentication, so OS authentication. You will not need to put that if you're on a Unix or a Linux system, but you will on Windows. And then a couple entries down, we have the trace level. The trace level can be either set to off, it can be set to user, admin, or support. They're just varying levels of tracing, and we can look at our trace file in just a moment. Now that we've configured our listener, let's now configure our client end. Now, from the client's perspective, we can have several different ways of tapping into our database. We can use a service name like I did up here, or we could use the Easy Connect naming method, which is only available in 10G, or we could use an LDAP directory. There's all sorts of options. We're going to focus on using a service name like here, using tnsnames.aura configuration file, and then I'll also show you an example of using Easy Connect. The easiest way to modify this is to go into netCA, and we configure our naming methods. So we hit next, and here are all of our available options on the left, And here are the selected naming methods. So our two selected naming methods are local naming, which is the TNS names.ora config file, and our easy connect naming. And you can change the order, the preference in which these are going to be run. So if I try to connect from a client, in this case, it's going to try the easy connect naming. If the syntax isn't right for that, then it will try local naming. So then we hit next, and it's complete. Now what that really did is it modified a file called sqlnet.ora. And all I want you to do is pay attention to this line, which is the names.directory path, and it has the naming methods. Let's do the easy connect naming method first. We simply say SQL plus the username / password, then an @ and either the computer name or the IP address that resolves to, then the port number followed by a / and then the SID name. Okay, so we got in. That's it. So this easy connect name is named that way just because there is no configuration with any configuration files at all involved. It's just all the information is right there in that string. Now, if you want to use the local naming method, now that involves the TNS names.ora configuration file, which is in the network admin directory by default. Let's open up that file. Now you can configure that file by launching netca, or you can configure it manually. It's up to you. I'm going to just do it from here. So tnsnames.ora. And here we can specify the connect service name. I mean, we can call it anything we want. For example, here we can say test. And all this is saying is that the word test resolves to this description down here. In other words, the word test resolves to the ORCL SID that's on the Johnson host port 1521. In fact, let's go ahead and save this. And the way to test this out is we can use our utility called TNS ping. Okay, so you simply say TNS ping and then the service name, and it should come back saying that it's just fine. Okay, so it told us that it was okay. Now, what would happen if we said TNS ping ORCL? Well, it would come back with an error saying couldn't resolve the name because that ORCL wasn't defined as a service in the tnsnames.ora file. So you can configure multiple service names in there. In fact, you can have multiple names for the same service. I'm going to show you how to configure your tnsnames.ora through netca, just so you get comfortable with both methods. So we would go to our local net service name configuration, and we can add. We hit next. Now the service name is the SID of the database we're trying to tap into. So our SID is ORCL, and then let's just do another TCP, and the host name is Johnson, and the port number is 1521, and yes, let's perform a test. Okay, now if it tells us invalid username and password, that's actually expected the first time you do that because it uses a bogus password. You need to type in the appropriate password, and then your test should be successful. Then you hit next, and then you actually give it a name. You can call it anything you want. For example, I can call mine Julie, and then hit next. Do I want to configure another one? No, I do not. And then I'm finished. So now to test this, we can do a TNS ping and then the service name. Looks great. We can do a TNS ping on our other one called test. And this should be fine too. Now, let's say that your TNS ping didn't work. Well, then you would kind of backtrack and say, you know what, does ping by itself work? Okay, ping is just an operating system utility that lets us know whether a node is alive. So we just say ping Johnson. Okay, good. Now let's say that this failed. Well, then what we would do is then say ping and perhaps the IP address. Maybe the IP address isn't getting resolved. If the IP address isn't working, then talk to your network administrator. Or just see if you can hit the outside world at all. For example, if my ping with one of my nodes isn't working, well then maybe I'd try, a ping with some external website. Make sure I'm getting some stuff back. Okay, so there we know that I have a connection to the outside world. We can also look at our log files and our trace files to see what's been going on with our tools. For example, with our listener control, remember that's LSNR-CTL, we can set our tracing level. Okay, so here we could say set trace level support. What that means is we're getting really detailed information about our listener trace, and then when we call Oracle for support, they're going to say, hey, you've been having trouble with your listener, send me your trace file and we can debug it for you. You can also configure where your listener log file is going to be. So here we're saying, okay, let's set our log directory to be directly under our C Oracle product directory. See, we can really put it anywhere we want to. Note that there is not an equal sign. It's just a space between what you're setting and the value you're setting it to. Likewise, you can set the log file. So here we can call our log file mylog.txt. Okay, so then if you want to see what all those values are, you can always say show log directory. Okay, and make sure that if you want to make this a permanent change that you say save config to save it in your listener.ora file. Okay, now the last thing I'd like to show you is how a distributed query works. That's simply a query that involves two or more databases, and we reference those databases from the SQL statement with what we call a database link. And so what I'm going to show you is how to create the database link, which involves our net services. So in this window, we're going to connect to ORCL2. So we'll set our SID to be ORCL2, and then we'll connect to our database. And just to prove to you that we are indeed connected to the correct one, select name from $, database. And then we'll open up a second window, and we'll set our SID up here to be ORCL. Select name from $, database. Now remember, a few minutes ago, we already created the tnsnames.ora entries to reference ORCL2. And just to test that, remember how we do that? We do a tns ping. Okay, so we can say tns ping ORCL2. And it tells us that it's okay. So we can access ORCL2 from ORCL. What I'd like to do now is create a distributed query. I'd like to do a join on two different tables. The first table will be, let's say, scott.emp under ORCL, and the second table will be scott.department in ORCL2. Now, when you have a distributed query, the tables don't necessarily have to be in the same schema, but that is the case here. So our end goal is to be able to do a select statement from here, saying, for example, select, I'll just use a real simple example, select user from dual at, and then the database link name. Well, we haven't set up our database link yet, so this statement's going to fail. But if you ever have this kind of error, just know that this means your database link is not correctly set up. Now, you can pretty much call your database link anything you want to as long as it's 8 characters or less. I like to name my link the same name as the Oracle SID that I'm referencing. The way we create our database link is we simply say create, and the word public is optional. If you put public in there, it means that it's accessible by anyone on the system. Database link, and we give it a name. Like I said, I'll call mine ORCL2. Now, if you want your link to be connecting as a particular user when it's being used, then you can have this clause. You can say connect to, and then the username, identified by, and then the password. Now, this password is going to be encrypted when you look this up in the data dictionary. And then the last clause is the using clause. In single quotes, you have the name that can be resolved by the TNS name. So we were able to successfully ping ORCL2, so that's what we're going to be using. Okay, so now to test our link, we can call a function like this. We can say select sysdate from dual at, and then test it out, ORCL2. If it comes back with some meaningful information, good. That means it's working. Now keep in mind that I'm logged in as the sysdba on ORCL. What's interesting is that I can now do a describe on the department table at ORCL2, and it's actually giving us the information for Scott's department table on this database over here. Notice that I didn't have to fully qualify it because this assumes that you're logging in as Scott. Now on my local database here, I still have to fully qualify the emp table. Okay, so describe scott.emp. Now the two columns that these have in common are the department numbers. So now we can go ahead and issue our query, and we can say, okay, let's select the emp number, e-name, salary, and department name from scott.emp. We'll give it table alias, and then department at ORCL2. Let's call this B. And now it makes our join clause really easy. We just say where A.department number equals B.department number. Beautiful. Now from up here, if you want to see in your data dictionary all of your database links, just do a describe on DBA, DB links, and you can grab the owner of the link, what the link name is, the username if you're logging in as someone special, what host it's pointing to, and then the created date. So here I'll say select DB link and username and host from DBA DB links. And we'll make the format a little prettier. And re-execute this. Now notice that the DB link shows up as the fully qualified. That .johnson tacked on the end is the machine name of this database. In fact, you can fully qualify it in your queries. If I say select sysdate from dual at orcl2.johnson, that will work just fine as well. So those are your distributed queries. Let's review what we covered in our nugget here. Remember, we talked about the heterogeneous distributed environment. So keep in mind that you don't have to have a purely Unix environment or purely Windows environment for all of your databases. It can be a hodgepodge of those different types. And you can even have different versions. And you can connect all those databases together using your net services. We also talked about some of the performance and security benefits. Remember how you can prevent certain IP addresses or invite certain IP addresses to use your listener. And we covered a little bit about performance, namely connection pooling, which we'll discuss in more detail in our next nugget on the shared server option. I showed you how to invoke the listener. Remember to do that, we say ls nr ctl, and we have several different options. If you ever get lost, remember just type in help. And the whole purpose of the listener is to listen for incoming client connections and hand it off to the database. And then we talked about our different naming methods, and we covered specifically local naming and the easy connect naming. Remember, our local naming is using the tnsnames.ora file that you have to configure. And if you look in your Oracle Home Network admin directory, you'll find that there. And we also have samples under this sample directory that sits there as well. And then we have the Easy Connect, which is new to 10G. You don't have to configure any files for that, so you do have to provide all the information up front here. We talked about some of our troubleshooting tools. On the OS level, you provide your ping. If that's alive, then you can go on to the next step. You can do a TNS ping to see if your naming is correct within Oracle. And then you can review your trace files and your log files. And then lastly, we have our distributed queries. And we create our distributed queries through database links. And you test the links with the @ sign and then the link name. In our case, it was ORCL2. I hope this was informative for you, and I'd like to thank you for viewing.